My name's Jeremy Niederjohn, and I'm pleased today to introduce a new offering, Lean Energy Analysis. My role at Johnson Controls, I'm responsible for strategy, within our building technologies and services business. And one of the things that we focus on is trying to find innovative ways to use data to better inform building owners. And I think you'll see with Lean Energy Analysis that it's one of those ways of taking advantage of data that every building has around utility bills. So Lean Energy Analysis is a new offering, a report for building owners that uses utility bill data and identifies energy conservation measures and associated savings within their buildings. Everybody's very familiar with Energy Star and Portfolio Manager, and that does a great job of benchmarking buildings. What Lean does is it extends some of the data within Energy Star, specifically utility bill data, and is able to provide further granularity on actual opportunities to reduce energy as well as monetize them. The name Lean Energy Analysis is kind of taken from the manufacturing sector, where Lean uses statistical and mathematical models to reduce labor and materials waste in manufacturing applications. Similar to that, Lean Energy Analysis uses mathematics and statistical models to identify energy waste in buildings. One of the key components and fundamental tenets around Lean Energy Analysis was to use as little data as possible to inform building owners and to use data that's readily available. So one of the key components about Lean is the minimal data that's required. And you can see it here. It's utility bills. We can do it with as little as 1 year, but we prefer 2 to 3 years for increased resolution. Square footage of the facility, and then the building type. So building type is medical office building, a hospital, a dormitory, public school, something like that. Using just those 3 pieces of data, we're able to identify 14 discrete energy conservation measures. And when we say energy conservation measures, we mean things like efficiency of a cooling system, efficiency of a heating system, making recommendations on optimization of set points, lighting, insulation, a number of different things that kind of cover the gamut of energy in buildings. Along with minimal energy, another key piece of Lean was that we wanted to be able to apply it to as many buildings as possible in the market. So a key thing was that we wanted to empower building owners to use the data that they already have to gain more insight and make that available to as broad a market as possible. And so Lean Energy Analysis is applicable through a single building all the way up through a portfolio of buildings, and regardless of the vertical market or building type that you're interested in doing it. So we've had building owners where we've used Lean that are single buildings, and for them, the opportunity is to just get their arms around, is there something I can do in my building around energy, and is it worth making the investment? So with a very small investment and with very little data, we can provide them a report that says, here's the opportunity to reduce energy in your facility, and here are the activities you could do. Similarly, for an enterprise, and an enterprise in this could be a campus, could be a school district that has 15, 20, 40 buildings, whatever the number, we use Lean Energy Analysis to go in there and look at the entire portfolio of buildings and allow them to prioritize and understand where are the focus areas for building for energy efficiency. For a portfolio, we've worked with commercial real estate owners that are considering the acquisition of a building to use Lean Energy Analysis to identify where there's an opportunity to increase the value of that building post-acquisition. And then underlying all of these is a recent application of Lean where a building owner was thinking about making a capital investment, in fact an investment in a chiller, and in conjunction with that considered other energy retrofits that might enhance their building and potentially have an impact on that capital investment. So I talked about the data that's required for Lean. The way Lean works, we take utility bill data and we marry it up with weather data to create an energy model of the building, a statistical model of the energy use in that building. And you can imagine that model, the coefficients, correspond to components of energy use in that building, so the base load and the weather-dependent piece of the energy. And with traditional benchmarking, it's taken the entire building and benchmarked it against a population of buildings. With Lean Energy Analysis, we break that building into its component energy pieces and benchmark each one of those pieces against a population of thousands of buildings of similar type in each of those components in those buildings. So you get far more granularity on where the opportunity is to target energy savings and hopefully understand what the value is of those opportunities. These coefficients that I described that make up this model, this statistical representation of energy in the building, have physical meaning. And in creating Lean, we've used a lot of Johnson Controls experience with energy projects and performance contracting to really understand that when we identify this coefficient, it typically leads to these facility improvement measures, and we provide a lot of details to customers around where there's an actual opportunity to affect their energy spend. So if you were to get a Lean energy analysis, this is what it would look like. This is one of the pages from the report. And again, we just have a small window here to introduce it. In the top right, you see the overall opportunity for energy reduction. So for this facility, it's estimated at $290,000, which is about 9% of their energy spend. And that potential reduction is made up of the recommendations that you see there. So it's things like set points, it's looking at your economizers in the facility, opportunity for efficiency of your cooling system, even comments about insulation. So to get those recommendations, it's again looking at this statistical model that's built, and we build one for electricity, and if the data is there for fossil fuels, we'll build it for fossil fuel as well. And we take those models and again compare the benchmarks against the population data set. So as an example, in the electricity chart there, you can see there's a sloping piece of that. That sloping line indicates how much more energy is being used in that facility as the temperature gets warmer. So you can understand that as that line becomes more vertical, it suggests that with a smaller temperature change, there's a lot more energy use, and thus a less efficient cooling system. So it's those kinds of coefficients, like the slope of that line, where the changeover exists, that we benchmark against a similar building set. And then finally, in the bottom right is a breakdown of the energy savings. So this helps a building owner identify, of that $290,000, how much of it is low-hanging fruit? How much of it is stuff that might come from low-cost or no-cost kind of changes, so controls changes, set point changes, things like that. How much of it also requires a capital investment? So we give them some perspective on where the opportunity lies. The natural next question when we typically talk about Lean is, how accurate is it? And I should preface this with an understanding of where Lean typically fits in the process. Lean is generally used pretty early on in the process to help a building owner get an idea, get their arms around what the opportunity is, the scale of it, and what makes it up. That being said, Lean is pretty accurate. You can see here we compared Lean to an interval data-based model. So there's several of these on the market where they use 15-minute interval data and do remote audits of buildings. And these are great tools. However, we've found with some buildings that getting 15-minute interval data for a year can be challenging. We also compared it to an actual on-site audit as well as a project that's in measurement and verification. And you can see that overall Lean compares and stacks up very well. What's not shown here is that the energy improvement measures that are recommended also align very well. So again, Lean's role is relatively early in the process to help people get their arms around what the opportunity would be, and you'd likely follow up with a more detailed audit or an engagement with an energy services company. But coming back to that example of an enterprise customer, for instance, when you took that next step and engaged with somebody, you'd be able to more intelligently and more proactively go after the buildings that appear to have the highest opportunity, as opposed to potentially a manual audit of a number of different buildings. Thanks for your time today. We're excited about Lean. I think it's an opportunity to bring energy efficiency and the identification of potential energy saving opportunities to a much larger piece of the market because of the very low costs and the ease of data that's part of it. So, thanks very much.